So here we've been asked to find, we're just going to go through the first example to start with and then we'll go to the second one. We've been asked to find the area under the curve, the total area under the curve of a function x cubed minus 3 between 0 and 2. If you've got a graphics calculator, I'd always advise graphing it. There's also a trick on your graphics calculator for finding your area very quickly, but it's important that we know how to do it both with and without a calculator. Cool? The first thing I always like to do when I get this is identify what I need to do, what operation am I dealing with. So they've given us a function. What do I need to do to that function to find the area? And we know that's integration, correct? So we know we've got to, so this is literally my thought process as I approach this problem. So I say we want the area, so I've identified that keyword in the question. I want the area between that domain. I'm thinking I need to do some integration, but before I do that I need to check if there's a positive and a negative area. Now I know there'll be a positive and a negative area cancelling out if what occurs? If there's an x-intercept. There is one scenario where that won't be the case. Anyone think of a function where that may not be the case? When you've got a turning point on your x-axis. Cool? Does that make sense? So if I had a function that did this, that would not go through a positive negative, would it? But in every other scenario, when it cuts the x-axis, you'll know that you've got a positive and a negative area. Cool? Very easy with a calculator. If you haven't got that, you'll have to go back to the old school method of finding an intercept, where we let y equal 0 and rearrange to find our unknown. X. Cool? I've done that here, and I've got x is equal to 1.44, or root 3 of 3. Third root, cube root of 3. Either way, that's inside my domain. So what's that tell me? When I get to this point here, I know I've got to do something. What is that telling me? Pardon? I need to split it up. And this is where we got to yesterday, and it's probably not, again, we ran a little bit short on time, so I was a bit rushed. But we got to the point here where we had split our function into the two parts. Happy with that? Now, left a bit of working off here. Well, not working, but something that I like to do in my head to help me identify what operation I'm using, what I'm doing. What am I trying to find again? Tanner, what do you reckon I'm trying to find?
Yeah.
And why did I break it into two sections?
Because some of it is, if you didn't break it into two sections, you would end up with an answer because the negative x values.
Yep, so my answer is going to be below what it should be because my negative values take away from my positive values, don't they? So what I need to do is identify what? I've broken this into segments, haven't I? Could I give these segments names? Pardon? A and B? Yep, I could give them A and B. Is there a way I could just maybe describe some of their properties with a name? Negative and positive. So which part of this graph represents the negative area? The first part. So I'd put above this, if it was me, I'd put negative. What do I do here? Positive. Cool. Why am I doing that? You don't have to do that, but why am I choosing to do that? What do you expect this answer to be? So what do I need to do? Apply a negative value to it, don't I? Don't I? What happens if I just keep the negativity of that added to the positive value there? What's going to occur? Is anything going to change? I may as well have just done it the fast way. So let's go through and find our negative area and a positive area, and let's see if we can find a way to get around or how to deal with these problems. So what do you think? What's my first step after that? Sub my values in. Which one goes first? 1.44, so the power of 4 over 4 minus 3 times 1.44. What do I do with that now? I close the bracket. Yep, I can do that. Add another bracket now. Take away 0 to the power of 4 over 4 is minus 3 times 0. So I don't need to do anything like that, do I? That's done. I'll put minus 0 so we know. And bracket, now what do I do? Plus. So what's the first value here? 2 to the power of 4 over 4 minus 3 times 2. Brackets, I'll do the big brackets again. Minus 1.44 over 4, that's the power of 4, minus 3 times 1.44. Who knows how to do that in their head? Toby?
3.245.
That one there is 3.245. 3.245 plus.
Will that?
Will that be positive or negative? Negative 3.245. Very good. Just going to keep that in brackets. Plus
6.49.
6.49. Is that the total of all that? Okay. So we've got two areas here now. Again, what should I write above these? So which one's negative? Why am I making a point of doing that?
Please, so we've got to do the second one.
Yep, so what's the second one? When you get 1.25, so that would make sense because it looks like there'll be a smaller amount of error. So 1.25, and that was that minus that. Yep. Very good. It is going to be negative. So I've made a point. This is why I wanted to pull it up. What do you think I should do? What am I looking for? Do I want a negative area? So what am I really looking for? I want negative 3.249. I want that to be positive. So how could I do that? Times by negative 1. If I wanted. Which would give me 3.245 plus 1.25. Now there's probably a formula. You've probably got some formula in your books that works out that. Do you need a formula? What do you need to really do to approach these problems? I'd advise that you probably just need to conceptually understand what you're doing. If you conceptually understand what you're doing, you know that you need a positive value there. So if I hit all that in my calculator, I should end up with 5.495 units. Oh, 4. Very good. Now, what I want you to do in your calculator, I want you to go to the graph section. So the graph section. Everyone get your calculators out? Because that's all well and good, but I'd love to check. I'm going to rub this out now. So graph, I want you to graph that function, just that function. So x cubed minus 3. 2. G solve. Go to your second set of options. So as you go G solve, go across. So shift G solve. And then I want you to hit the one that looks like this. I think it's that dx. Once you've hit that, enter 0. Enter 0. Obviously hit enter. Enter 1.44.
I clicked the thing and then. Oh.
3.245. Now I want you to do the same thing again repeat,
Negative, negative.
hit 1.44, enter, then 2, enter. And add those two values up.
And then enter.
What do you notice? What have I just showed you? They do it on the calculator. If you didn't understand this though, now what I want you to do is do exactly the same thing, but go from 0 to 2. On your calculator, 0 to 2. See if the calculator accounts positive and negative.
How do you know, mate?
Stop it.
Just hit exit and then re-go through it. I don't know, there's probably a way, but I just exit and Negative. So what does that say about when the calculator finds your area? Does it account for total error or does it subtract them? So you need to be very careful. Is there a way I could find the intercept very quickly with my calculator? There is a button. I believe it's the root button.
In the FPX and find out
The total error? Yep.
So whether it's negative and account for that.
Cool. You can use that. I didn't know you could do that. I just put it up like that. Sweet. What's the value of doing that? Very easy way to check you're starting to show you mathematics. It's not good enough just to say use graphics calculator. Clear? But if you've got that, then you've always got a way that you can check your responses. Clear?